All right, for practice worksheet 4.3, we're given some information about integrals, but we don't have an actual function equation. So integral from -1 to 1 of f of x dx has an area of 5. From 1 to 4, the area is -2. From -1 to 1 under h of x, that is area is equal to 7. So find each integral. So you're just looking for some of those properties that we use. So if I switch this, so it's the integral from 4 to 1, that should just be equal to the negative integral from 1 to 4 of f of x dx. So that's equal to -2. So positive 2. You don't have to show me the negative. I'm just trying to explain my work here. All right, if I want to go from -1 to 4 f of x dx, that's not what I'm given, but I'm given -1 to 1 and then 1 to 4. So you can break it up like that. We had a property that said if there's some c value sitting between a and b, you can break the integral up into those parts. So we're going to go from -1 to 1 and find that area, and then pick up from 1 and go to 4 and find that area. So I can just add those numbers. 5 plus -2 is equal to a net area of 3. For the next one, we've got the integral from -1 to 1 of 2 f of x plus 3 h of x. So what you're doing here, I know mathematically you might just start doing the math, but what you're allowed to do by the properties is say the 2 can come out in front of the integral from -1 to 1 of f of x dx. I'm allowed to add 3 times the integral from -1 to 1 of h of x dx. And so that's equal to 2 times 5 plus 3 times 7. So 10 plus 21 is 31. All right, for this one, be careful here. This plus 3 tends to trip people up. So, okay, first part's easy. This is the integral from -1 to 1 of f of x dx. They give me that number. But then what about 3 times the integral from -1 to 1 of just dx? We're not given that information, but remember, they don't need to give us that information. This area, it's a constant function at 3, and you're going from -1 to 1. So that is a rectangle that has a base of 2 and a height of 3. And it's above the x-axis. So this has an area of 6. All right, so the first area is 5. Second area is 6. Oh, 3 times. Or no, sorry. I almost did 3 times 6, but this area here is this picture. So yeah, just plus 6. So that equals 11. You don't have to pull the 3 out on that one. You could have left the 3 here. Maybe if I did that, I wouldn't have almost done 3 times 6. So just be careful there. And then what about this f of x minus 3? So you are shifting everything to the right 3 units. And I wouldn't want to get into like doing this. I guess I could. No, I don't want to get into doing this geometrically because if I try to do that, I don't know what f's graph looks like. But take a look at these bounds going from 2 to 4. So you might want to sketch a little bit of a graph here. So this graph is saying go from 2 to 4 to begin with. But x minus 3, that shifts the graph to the right 3 from where f of x was, right? Minus 3 says shift this whole graph to the right 3 units. So let's go back 3. Let's shift this to the left 3. If we go back left 3, we'll land on f of x. So if I subtract 3, I'm actually at -1. And if I subtract 3, I'm actually at 1. So really, this is the integral between -1 and 1 of just f of x dx. So that one's pretty tricky. So you're just getting 5. So whatever shift this was, I had to think about, okay, well, how do I get back to f of x so that I'm within the bounds that I was originally given? All right, for number 2. The integral from 3 to 8 is 6. The integral from 7 to 8 is 1. They're both of f of x dx. So the integral from 3 to 7. So I have the integral from 3 to 8. If I take the integral from 3 to 8 of f of x dx, and I subtract the integral from 7 to 8 of f of x dx, that would leave me with, it's this big area minus this little area. So that would leave me with the integral from 3 to 7, right? So that's just going to be 6 minus 1. That area is 5. The integral from 8 to 3, anytime you see bounds that are backwards like this, integration limits that are backwards like this, you should set it right by putting a negative out in front and saying it's the integral from 3 to 8 of f of x dx. So that's normally 6, so our answer is going to be negative 6. All right. For number 3, use the graph and the areas to evaluate each integral. So again, we're not, even if you know integration rules, I know some of you had it in AB Calc or Physics C, practice doing things geometrically because sometimes we have to do things geometrically. All right, so for this one, I've got a constant function that's going through 5. And I really should have drawn it this way because I'm going from negative 2 to 1. So I'm looking at this area here. This has a base of 3 and a height of 5. So that area is 15. For this one, we're going from 0 to 3. The constant function is at negative 160. So we're looking at this area, which is negative. It has a height of 160 and a base of 3. So let's see, 3 times 16 is 48. So this would be negative 480. The next one is still a constant function. It has a height of pi over 2, which is positive. I keep sketching this before I really look at the bounds. Going from negative 4 to 1. So you're looking at this area here. This base is 5 units. This height is pi over 2 units. 5 times pi over 2 is 5 pi over 2. For this next one, we have a line. We're going from 1/2 to 3/2. So let's see. So when we plug in 1/2 into negative 2x plus 4, so that becomes negative 1 plus 4. So 3. And then when we plug in 3 over 2 times negative 2, I get negative 3 plus 4. So that's 1. You have a line like that, which forms a trapezoid, the area underneath here. So the parallel sides are here and here. So we have a height of 3 and a height of 1. A base of 3 and a base of 1. The distance from 3 over 2 to 1 over 2 is 2 over 2, or 1 unit. So the area of that trapezoid is 1/2 times the height, which is the distance between the parallel bases, times the sum of the bases, 3 plus 1. 4 times 1/2 is 2. All right, same graph, but now we're going 0 to 4. So if I plug in 0, I get 4. If I plug in 4, I get negative 8 plus 4, so negative 4, like this. We need to know what this point is where we hit 0. So when is negative 2x plus 4 equal to 0? That's when x equals 2. And that's important because you need to know what is the size of the base here. These look symmetric the way I drew it, but I just want to be absolutely sure. So this has a height of 4, and this has a base of 2. This has a base of 2 and a height of 4. One's going to be positive. One's going to be negative. I guess their areas are 8 divided by 2, right? So either way, whether you show me that work or not, that is a net area of 0. Okay, for this one, let's sketch this over here. We're going from 2 to 8. When we plug in 2, we get 1 minus 3 is negative 2. And then when we plug in 8, we get 4 minus 3, which is 1. You can see I don't bother drawing anything to scale. When is this thing hitting 0? So when 1/2 x equals 3, multiplied by 2, when x equals 6. So the base here from 2 to 6 is 4, height of 2. Base here is 6 to 8 is 2, height of 1. So we have a negative area first, negative 1/2 times a base of 4 times a height of 2, plus 1/2 base of 2, height of 1. Negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. This is a graph that I talked about a lot in the beginning of pre-calc. You should know that the square root of 16 minus x squared is a semicircle, but we're only looking at it from negative 4 to 0. So it's really only a quarter of a circle that we're looking at. And so we should be able to find the area of a quarter circle. A circle is pi r squared. Sometimes people want to throw a 1/2 in there. So circle is pi r squared. We're going to do a fourth of that. So 1/4 pi times the radius is 4 squared. So 16 pi over 4 is 4 pi. Absolute value graph. Let me keep to my color scheme here. I'll go green next. Okay, absolute value graph. We're going from negative 2, which you would get 2 if you plug in, to 1, which you would have a height of 1. All right, where's the vertex? It's at 0. So you are still expected to know your parent functions. So this is a positive. We have 1/2 times a base of 2 and a height of 2, plus 1/2 base of 1, height of 1. Half of 4 is 2, plus 1/2 is 2.5, or 5 over 2. Integral of theta d theta. So don't let the theta trip you up. That's still a linear function. We're just saying, okay, when we plug in pi, we get pi. And when we plug in 2 pi into this y equals theta function, we get 2 pi. So that's still a linear function. This is still a trapezoid. The distance between the parallel bases is pi. The first parallel base has a height of pi. The second one is 2 pi. So this is 1/2 times the height, which is pi, times the sum of the bases, pi plus 2 pi. So 1/2 pi times 3 pi is 3 pi squared over 2. Right? This is 3 pi. You're multiplying by pi. That's 3 pi squared, and then it's divided by 2. All right, for this one, going from negative 5 to positive 4. When you plug in negative 5, you get 5 minus 2, which is 3. And when you plug in 4, you get negative 4 minus 2, which is negative 6. This is a line of some sort. Where does the graph hit the x-axis? When is negative x minus 2 equal to 0? That's when x equals negative 2. All right, so I like to draw right into my picture here. So this base is going from negative 2 to negative 3. So that's a base of 3. I'm sorry, from negative 2 to negative 5. And it also has a height of 3. Then this base goes from negative 2 to 4. So that's a length of 6. And it's going down to negative 6. So we have positive 1/2 times 3 times 3 minus 1/2 times 6 times 6. So 9 over 2 minus 18 minus, I guess I should have done minus 36 over 2. No reason to reduce that, right? So that I can more easily subtract. So that's negative 27 over 2. Negative 13.5. Okay, back to a constant function. So for this one, we have a height of 4. We're going from 3 to 5. So that's a height of 4 and a base of 2. So that area is 8. And for this one, this is more abstract, right? So 3 times t. So let's graph 3t from A to B. So, okay, 3t definitely goes through 0, 0. I don't know what A and B are, though, so this is kind of interesting. Could be that A is negative, B is positive. It could be that they're both positive. Or it could be that, Or it could be that, so you could get a trapezoid, you could get contesting areas here, or they could both be negative. So let's think about this. Let's see. So whatever this is 3 times b. Oops, my pen stopped working. So this is 3 times b. Whatever this is 3 times a in either case, right? 3b, 3a. Okay, so let's see. So in this case, it would be like 1/2 times 3a times a plus 1/2 times 3b times b. And this one would have been negative. So that's negative 3/2 a squared plus 3/2 b squared. That would be that one. What would this one be? Do we get something similar? Let's see, because I can factor that a bit. This one would be like 1/2 times the height, which is b minus a, times the sum of the bases, which is 3a plus 3b. Can we show that these two things are equivalent? I think so. I can factor 3 out. B minus a times a plus b. Gosh, it looks so close to a difference of squares. If I could only factor a negative, which I can, out of the b minus a to turn it around. Yep. Okay, so then that's going to give me negative 3/2 times a squared minus b squared. Can I make this look like that? Factor out a negative 3/2, a squared minus b squared. They're the same thing. So apparently this is going to be negative 3/2 over a squared minus b squared. And I'm convinced enough to not do this the other way. I know I haven't considered like what if they're both negative, but you know, it really doesn't matter. You're going to get the same thing, right? You're going to get something like this, and it'll just be another trapezoid on the negative side. Okay, I think I'm happy with that. What about this section here? Is this our last? Yeah, this is our last page. Okay. We're given a bunch of integrals again with different bounds and a couple different functions. So find each integral. So 3 to 3, I'm not even going to look up here. I'm going to say 0. 3 to 10, okay, I have to look up here. So 3 to 10. Now, we have negative 2 to 3, and we have negative 2 to 10. So if I can subtract the little negative 2 to 3 chunk out of this one, I would be left with 3 to 10. So that's going to be the integral from negative 2 to 10, the whole thing, f of x dx. This is more than I want. I want to cut out the area from negative 2 to 3 and see what I'm left with. So 20 minus 12, I would be left with a net area of 8. This is backwards, so we want to set it right by putting a negative out in front. And then we check our information up here. Negative 2 to 3 is 12, so this is negative 12. For this one, we have constants again. So I'm not going to write it out like I did on the first page. The bounds are correct, right, for what we have for f of x and g of x. So this is going to be 2 times the area that was given for f of x minus 5 times the area that was given for g of x. 24 minus 20 is 4. Remember to be careful with this again. So, okay, the area from negative 3 to 2 of f of x was 12. And then what about this area of 3? Remember, it's going to be the height of the function times the distance between, times the distance between the two boundaries here. So 3 minus negative 2. And if you need to see that visually, just do a very quick sketch. It's easy to say 3. We're going from negative 2 to 3. So, yeah, this is a distance of 5. This is a height of 3. I'm getting 12 plus 3 times 5. 12 plus 15 is 27. Okay, and then 0 to 5. Remember what this means? This is a shift to the right, 2. But we want to send it back to where it was. So move back or left 2 units. So if I do that, from 0, go back 2, you're at negative 2. From 3, go back 2, you're at 3. Now you're only at f of x dx instead of the shifted right version of that. And that area is it 12? Yes, that area is 12. Use geometry to find the following integral. Okay, so we're going to graph it first. From -1 to 4. Plug in -1, you get 6 plus 3 is 9. Plug in 4, you get 6 minus 12 is -6. Oops, meant to put a -6 here. Erase that. This is some sort of line that goes like that. And then where is that part? When is 6 minus 3x equal to 1/2? I would say when x equals 2. Okay, so this area, this triangle has a base of 3 and a height of 9. And this one has a base from 2 to 4, so a base of 2 and a height of 6. So it's 1/2 times base times height minus 1/2, because the other one's negative, times base times height. 27 over 2 minus, I'm not going to reduce here because I want to combine, so minus 12 over 2 is 15 over 2. All right, so we won't always be able to use geometry, but when we have linear functions or constant functions or square root of a backwards difference of squares functions, where'd that go? This one, G. If we can sketch a graph and we get a circle, a triangle, a trapezoid, a rectangle, something like that, then we are able to calculate the area without really any major calculus.